In this video, we will talk about radical expressions and learn how to evaluate those. So when we talk about a radical, we're dealing with a root sign, this sign here, okay? And when there's no number written in the v part, then we are actually taking a square root. And what that means is we're looking to see what the roots are. We can define a square root as c squared is going to equal a, okay? And if this is true, then c is called a square root. So for example, I can say what squared, c squared, equals 9. So what number when squared is going to equal 9? Well, I know I can square 3 and get 9, or I can actually square negative 3. So by definition, my square roots are 3 and negative 3. So to work backwards, I ask, what is the square root of 9? Okay? And when I put it like this, I am looking for the number 3. Okay? So that's how we end up with our radical expressions, with our radical denoted like this, and the whatever we have underneath the radical is called our radicand. And one of the first things we want to be able to do is evaluate our radical expression. So for example here, once again, this is in function notation. I have a 4 in for x, and what this tells me is I go to my function named f. Wherever I have an x, I'm going to plug in a 4. So this becomes minus the square root of 2 times 4 plus 1. All I've done is go to my function and plug in 4 for x. That is equal to minus the square root of 2 times 4 is 8 plus 1. This is equal to minus the square root of 9, or I can call this minus 3, because 3 I can plug in for the square root of 9. I just went through that, and then I have the negative sign out front. Similarly, I can plug in 0. I get minus the square root of 2 times 0 plus 1. I know that 0 times anything is 0, so this is just going to be equal to minus the square root of 1. The square root of 1 is just 1, but I have this negative out front, so this is going to be negative 1. I can look at f of negative 1. This is going to be minus the square root of 2 times negative 1 plus 1. Okay? Or what happens here is I get minus the square root of minus 1. Whenever I end up with a negative underneath my radical, that's a big uh-oh, for now anyway. And what it tells me is that there is no real number. Okay, in other words, the value does not exist as a real number. Okay, so when you end up with a negative 1 or a negative of any kind underneath your radical, if you're taking a square root, if you're taking a cube root, it's different. Okay, why? Because I got to ask myself, what negative 1 times what? What can I square negative 1 and end up with a negative 1? Well, I never can. What times itself equals negative 1? Nothing. Okay, but now if I'm taking a cube root of negative 1, I can ask myself, what times itself 3 times gives me a negative 1? Well, in that case, negative 1 times negative 1 times negative 1. Okay, so when we're doing cube roots, it's okay, or odd roots, it's okay to have a negative underneath the radical. If you're doing square roots or fourth roots, even roots, then it is not okay to have a negative under the radical. And in this case, I did have a negative under radical, so I say that it does not exist as a real number. Okay. Later on, we will show how it exists. Finally, the last one says evaluate f of negative 1/2. So again, I can go to my radical. I can plug in negative 1/2. Okay, plus 1. What I end up in here is minus the square root of, this becomes negative 1 plus 1. So this is going to be minus square root of 0. Square root of 0 is actually 0, times that negative 1 is still 0, so my answer would be 0 for that. So once again, now we have turned our attention to radicals. We denote them using this. When there's no number written here, it is implied that we're taking a square root. The number up underneath the radical is called the radicand. And when you're asked to evaluate, you simply just plug in your function for x. If you end up with a negative underneath the radical sign and you are taking an even root, then your answer does not exist as a real number.